Good evening, students. Welcome back to PPS online class. Today, as we uh, discussed earlier, that we are going to start your fifth unit, Unit 5. In that, the first topic, which is searching and sorting. After that, we also need to discuss about asymptotic notations that we will do once we complete this searching and sorting. So, your complete your entire syllabus. This is what we have Unit 5 syllabus. We need to discuss about searching and sorting. So, in that basic searching in an array of elements, we will do. So, searching techniques. We have two different types of searching techniques. One is linear search, and the other one is binary search. Hopefully, in today's session only, I will try to discuss these two techniques, how we do searching in linear search technique and how we do searching in binary search technique. Then in tomorrow's class, hopefully we will discuss about the sorting algorithms. We have different sorting algorithms, around six different sorting algorithms we have in computer science. But among the six different, we need to discuss only three, the basic three, which are bubble sort, insertion sort, and selection sort. We'll try to discuss these three sorting algorithms in tomorrow's session. And with that, we left with only the order of complexity concepts, that is asymptotic notations and some examples on asymptotic notations. Okay, it is somewhat related to your mathematics, asymptotic notations concept. What is the uh, complexity, time complexity, and space complexity of an algorithm? And for that to measure, we have different what we call notations. In that, the first one, Vigo notation, theta notation, omega notation, that and all we will discuss. We will see. So quickly, we'll start today's class concept. That is, as we said, the searching techniques. We need to discuss about the searching techniques. This particular thing we will start basic searching techniques. In that, the linear search, it is also called as we said, as I said you, it is also called as sequential search, linear search or sequential search. This is the first approach, and the second approach is the binary search, second approach. So these two we will discuss in today's session. So first of all, before we proceed into the linear search thing, what exactly mean by searching? What exactly we do when we perform searching? What exactly we do, that we need to understand? Okay, it is one of the common operation in computer science. This searching or sorting, these two operations we perform many times. Whatever type of algorithm you apply, uh, in many different types of algorithms to be solved, we use this searching sorting algorithms, I mean searching sorting techniques. Okay, so the concept is very simple. A list will be given, a list of elements like an array of elements will be given to you, and you need to apply the searching technique, suitable searching techniques, to locate a particular item. So here, when we are saying locating, what exactly we are giving? I mean, when we are when they ask us whether this particular item, say suppose consider the example of this list. Here we have a list of 10 items, as the array name is A, and how many items we have here? 10 items we have here. The starting items index is 0, and the last items index is 9. As you can see, here we have that. Okay, here the starting items index is 0 and the last items index is 9. So this is what we have in hand. So let us assume we are searching for target 46. Okay, target 46. So where it is, my by seeing it we can say that the target 46 is residing at index 4 value, isn't it? So this is what we return now. When they ask us to search for item 46 in the given list of elements, what we return? We return the index where that element is located. Okay, as we this 46, it is located at index 4. This is 0th index, first index, second index, third index, fourth index. As this 46, it got located at fourth index, we are returning the index value 4. This is what the output from this algorithm, as simple as it is. We are searching for a particular item, and wherever we locate that item, we return the index value. That is what the algorithm will do. Searching algorithm will do. Here you can see, searching is a process used to find the location of a target among a list of objects. So we take the target which we need to locate in the list of objects, okay, which we need to locate in the list of object, and once it got located, what we return? We return the location index. సింపుల్ ప్రొసీజర్ అమ్మా. ఒక టార్గెట్ ఇస్తారు మనకు, ఐడెంటిఫై చేయమని, ఫైండ్ చేయమని ఒక లిస్ట్ ఆఫ్ ఐటమ్స్ లో. ఆ పర్టికులర్ టార్గెట్ కోసం ఆ లిస్ట్ ఆఫ్ ఐటమ్స్ ని మనం సెర్చ్ చేస్తాం. అండ్ వన్స్ దట్ టార్గెట్ గాట్ లొకేటెడ్, ఒకవేళ ఆ టార్గెట్ మనకు ఇచ్చిన లిస్ట్ లో ఉంటే, ఏ ఇండెక్స్ వాల్యూలో ఆ టార్గెట్ ఉందో ఆ ఇండెక్స్ వాల్యూని మనం రిటర్న్ చేస్తాం. వెరీ సింపుల్ టెక్నిక్. ఓకే, సో ఇన్ అన్ array, searching means that given a value, here again target, finding the location, that is nothing but index of the first occurrence of that element in the array in which contains the value, array which contains the value. So there may be possibility that we may have 46 after this as well. Okay, you may have repetition. There is no such constraint. You may have redundant. You may have repeated item 46 once again. Okay, so what we are looking for, we are just looking for the first occurrence of such item. Even if you have the repeated 46 value, let us assume here one more 46 you have, like this. Then what we look for, as we start the searching process from the 0th index, okay, from index 0, as we start the searching process from the 0th index, we always look for the first occurrence of that element. If it is linear sequential search, we always start the searching process from 0th index. Okay, in binary search we follow the different approach, that when it comes we will discuss more. For now, you simply remember, in linear search, in linear sequential search, we start the searching process from 0th index, and whenever we are looking for a particular item's existence in a list, it is nothing but the returning the index value of the first occurrence of that element. Okay, so wherever you found that element in the first occurrence, that index value only we will return. So this is how the searching technique will work. Simple thing, given a target value, finding the location of the target in a given list of items. Okay, so here, yeah, as we said, there are two basic searching techniques we have. One is the linear sequential search. This technique, it is the first technique, linear sequential search, and this is binary search, it is the second technique. Okay, so when we have to apply this linear search and when we have to apply this binary search, in the sense, there are certain parameters, certain constraints, certain conditions, we can say. So this linear search, it is very easy to apply, but very complex when it is operated. Okay, because it will consume, we can say it will consume more number of computational resources. మీ కంప్యూటర్ పవర్ ఎక్కువ కావాలమ్మా లీనియర్ సీక్వెన్షియల్ సెర్చ్ అప్లై చేయాలి అంటే, because it deals with more number of comparisons before it finds the element in your list. Okay, it does a lot of comparisons before finding the item in your list. So that's the reason it is heavy computational resources consuming your linear sequential search. So how to choose the best search technique for your problem statement, in the sense, okay, we need to focus on three parameters, as I said, three conditions, as I said. three parameters. In that, the first one is size of the list, size of list. This is the first parameter. Second parameter is frequency of searching. How frequently you are performing searching technique. Okay, so frequency of searching. And the last one is order of the list. Third one is the order of the list. So these three techniques, these three parameters we need to focus on. Based on that only we will select the best suited searching technique for our problem statement. So first one, the size of the list. If it is small, say less than 50, then apply the linear search. Then apply linear search. If the list size, if it is having less than 50 items, go for linear search. Okay, and if it is large, when I am saying, if it is greater than 50, obviously our only option is binary search. Go for binary search. List chinnaga undante, less than 50 items unnayante linear search apply cheyochu. List greater than 50 undante binary search ki vellali. Okay, then frequency of searching. If it is searched too frequently, then we have to go for binary search. Less frequently, we have to go for what we call linear search. Okay, that also I will write here. Less frequent. Yeah, here you. Okay, just I have done some mistake. This you remove from here and write here. If it is small, then go for linear. Here you write linear on top, and here also this is in case if it is large, go for binary. Here you write binary. Okay, size of the list. If it is small, go for linear search operation, and the size of the list, if it is large, go for binary search. Small, how to identify small or large? If the items are less than 50, we call it as small. If the items are greater than 50, we call it as large list. As simple as it is. Okay, so then if the frequency of searching, if it is less frequent, go for linear search. If it is too frequent, okay, if it is too frequent, then go for binary search. And finally, the order of the list. If it is unordered, if it is not in order, then go for linear search. Not in order. Order in the sense whether the list is sorted order or not. That only we are talking about. If it is not in order, go for linear search, and if it is in order, go for binary search. Ordered list aithe binary search ki ellali. Unordered list, that is not in ordered list aithe, we have to go for linear search algorithm. Ante మనం binary search apply cheyali ante list size వచ్చేసి చాలా large undali, and frequency of operations we have to perform a lot of times searching operation, then only go for binary. If your problem comes under that, go for binary search. And if you have a sorted list, ordered list, then also you can go for binary list. ఒకవేళ list sorted order లో లేకపోతే our only option is linear search. Because binary search we can apply only if the list is in sorted order. By seeing the technique, you will understand why this approach needs a sorted list. Okay, so linear sequential search requires the small lists. Okay, small size lists, small size arrays. And whenever you have less frequently, whenever you are performing the searching technique less frequently, you can go for the linear search. And if the list is not in order, If the list is not in order, then also you can go for linear sequential search. Okay. So based on these three parameters, size of the list, frequency of the searching, and order of the list, we can select which operation, which searching technique we have to apply for our searching problem. Hope you understood, ma. So linear sequential search, quickly we discuss. So what we do in linear sequential search, we search the target from the beginning of the list. We start our searching from the beginning of the list and look for the target each item, okay, at once, okay, and we'll continue until we reach the end of the list. One item at a time, we do the comparison with the target. If it matches, we stop the search, and there itself we return the index wherever we got the wherever we found the matching. There itself we return the index, and if it is not matched, we'll go to the next element and we'll search there. Okay, we'll look for the matching over there, and this process till what extent we perform until and unless we reach the end of the list. See here how we are starting the search operation from the beginning of the list. We are searching, we are starting the search operation until what extent we are continuing this operation until the target is found. This is the first case of termination. If the target is found, there only the algorithm will stop. And in case if the target is not found, where it will stop in the sense until the end of the list is reached. This is the second condition where the algorithm will stop. If the target is found, the algorithm will stop there itself and returns the index value. And if the target is not found in the list, the algorithm searches till the end of the list, and once the end of the list is reached, that is no target found case, there only the operation will stop. Okay, we have a diagrammatical explanation for this linear sequential search in our next slide. Just focus on this. As you can see here, total 12 elements we have in our list, because the index, as you can see, it is starting from 0 and it is ending at 11. So total number of items we have 12. Okay, and in the first attempt we are looking for target 62. Let us assume we are looking for target 62. Our target is 62, we are saying. So what we do, as I said, we always start the searching process from the beginning of the list. So this is the point. We call it as the beginning of the list. So we compare the first index, that is 0th index, with the given target value. So as you can see, target is 62 and we are comparing this 62 with 4. It is a no match, not equals. It is a no match. So what we have to do, we need to go for the next, simply we need to increase the index and we need to go to the next item to be matched, to be compared. So again, here also the target will be compared. 62 got compared with 21. Again, it is a no match. So what we do, again we increment the index value from 1 to 2 and we compare the target with index 2 item. Here index 2 item is 36, as you can see. So our target 62 got compared with 36. Again it is a no match, as you can see. So simply increase the index from 2 to 3 now and go to the third index item, which is 14. Compare 62 with 14. Again here also it is a no match. So one more time increment the index and go to the next index item, which is 62. So now our target is 62 and fourth index item is also 62. So it is a match. So if it is a match, what we have to, we need to return this index value. The index value 4 we need to return as our result, as our output, so that we can print the target 64 is found at index 4. Like that we can print. Okay, this is what the searching means. We simply identify the location where the target will be found in our searching process. Okay, so this is how the locating data in an unordered list. As you can see, the list size is small and the items are not in order. Okay, so that's the reason we applied the linear sequential search, and how this operation works I have given the idea. So this particular case we call it as a target found case. where the index value of the target will be returned. So target found case antaramma దీన్ని, where the index of the index of the item found will be returned. Where we found the target, at index 4 is found, so we are returning this index 4 as an output from the program, from the algorithm. Okay, so there is another case where the target not found. So we have in this slide that particular thing, we call it as the unsuccessful searching, because here when we look whatever target we are looking for will not found the target in the given list. So here our target, we said 72. As you can see here, our target is 72. So again, as it is a linear sequential search, we need to start the searching process from the first item. So this 4 will be compared with 72. Again, it is a no match. So if it is a no match, we have to just increment the index value and go to the next item, that is 21. Okay, next indexed item, that is 21. So again, compare 21. Now our target is, as you know, 72. So 21 we are comparing with 72. Again, it is a no match. So if it is a no match, one more time, increment the index, check with 36, check with 14, check with 62. That and all I have not given. So one more random case we are doing. I mean, this algorithm will not jump like this one, because all that I am not showing here. It is just the continuation. I need to put these dots over here. It is just the continuation. Okay. In the same way how we compared 21 with 72, we also compare 36 by incrementing the index value. We also compare the 36 with 72, 14 with 72, 62 with 72, and then 91 case here I have shown with index, where index value 5, we are comparing the 91 with 72. As you can see here, 91 with 72, and again it is also a no match. So likewise, till what extent we compare elements, till we reach the end of the list, here you can see, till we reach the end of the list, this particular point. Okay, once you reach the end of the list, and even you have not found the target in the given list, that means it is an unsuccessful case, or target not found case. We call it as target not found case. Okay, so target not found, target not found case. So in this particular case, what index we return? Because if the target is found, means wherever we got the target, that particular index we are returning. If the target is found at index 0, means we are returning 0. If the target is found at index 6, means we are returning 6. If the target is found at index 10, means we are returning 10. But if the target is not found, then what we return from the algorithm? So simply to indicate an unsuccessful search operation in a list, we return -1. Do remember this one. What we return? We return -1 to indicate the unsuccessful search. Okay, if the search is successful, we return the item, we return the index wherever we got the item, wherever we were able to find that item, that index value we return. But if the search is unsuccessful, we simply return -1. Okay, so simple flow chart for that one is given over here. Sequential search, we are calling our algorithm as sequential search. Okay, and we took a simple loop with index, and the index initially 0, because the index will start from 0, and maximum size, we are running till maximum size. Okay, because we kept less than, so it will not reach the sign, it will reach up to size -1 only, because we know index always start from 0 and ends at maximum size -1. So this is the termination condition, and this is the initialization. And as you can see, the updation every time, in every iteration, we are simply incrementing the index value by 1, so that it will compare all the items present in the list. Okay, so in every iteration, as you can see, what we are doing, we are keeping a condition and we are checking list of that particular index. So in the initial case, list of 0. In the first case, index value will be 0. So list of 0 will be compared with what? With target. List of 0 we are comparing with target. If this is a match, if this is true, then what we are doing? We are simply returning index. We are simply returning index. If this particular condition is false, what we are doing? We are not doing anything. We are simply going back and incrementing the index and checking with the next item. Likewise, we do the testing comparison over here with all the items, and if at all any particular item in the list matches with the target, we return that index value. We return that index value. See here, return index we are saying. Return that index value. If none of the items we reached the maximum size, index value size ki reach ayindi, maximum size ki reach ayindi, even though we didn't found that item in the list. So then what we have to simply come out of it and return -1. Okay, return -1. So that is how we perform the what we call linear sequential search. Whenever there is a match, the program is ending with that index, and whenever there is no match, the program is ending with -1. Okay, whenever we found the item, that index value we are returning, and whenever we were failed to found that item, an unsuccessful search case, we return -1 to indicate the unsuccessful search. Hopefully it is clear. Only two possibilities, ma'am. Coming out of the algorithm, only two possibilities: whenever we are finding the items or whenever we are not finding the item. Okay. So this particular program demonstration, as you can see, I'm taking this with the help of, I'm writing this program with the help of a function, and we call that function as sequential search, SEQ sequential search. And to this we are returning different things. The first one is the array list we are returning. Second is the target to found, and third is the size of the array. Three items we are passing, three parameters we are passing to this function. First one is the list, second one is the target integer type, third one is the maximum size of your list, maximum number of items present in the list. That is the third parameter. Okay. So here I took some random sized 20 sized list, and I'll store my target item to be found in target, and index to run, I took this index, and I just to run a loop, and size I took. Okay, size I took. Okay, so now what I'm doing, simply for reading items, I'm taking the size input, and that many elements I'm reading from the user, and simply reading, for reading purpose, I'm running a loop over here. Scanf with only 1% ILD, I'm running a loop over here. So as many items you say to enter, to input, to have in the list, that many items it will read from the end user. Okay. Then once the items are read into the list, we are calling our function, as you can see. Then we are reading the target also now. Okay, target we are reading here, and we are storing into a variable called target, and then we are calling our function sequential search. Okay, and to this sequential search we are passing the list which we read just now, and we are passing the target, and we are also passing the size. Okay, with this three, where the control goes, once you called the function sequential search, the control jumps from here to the function definition. Here we have the function definition in our next slide. As you can see, whatever list you are passing from there, that list will come here. Whatever target you are passing there, that target will come here. Whatever size you are passing there, that size will come over here. And internally, here I am declaring one variable with name index, because our final outcome, we need to return the index only. So index equals to 0 I took, index must be less than size I took, and index plus I took. So here list of index, every time I'm checking one item from the list with the target. Okay, in this iteration, every time I'm checking one item from the list with my target. So initially list of 0 will be compared with target, list of 1, then list of 2, list of 3, list of 4. Likewise, till you reach the end of the list, all items will be compared. In case if you don't found any item in the list, any target in the list, then the loop will come out. The loop will break and loop will come out. So in that case, when the loop is coming out, what we are returning? We are returning -1, as you can see here. Okay, if loop is not returning, a particular index valued item is matching with the target, that particular index value we are returning. Here you have very clearly. If a particular index valued item is matching with the target, that particular index value we return from the function. And whatever index value you return from the function, where it will go, whether you are returning -1 or you are returning index, where it will go, it will go back to the function call itself. Inside the calling portion, it will go back to the function itself, called function itself. So here, this particular area, here it will come. Okay, here it will come. As you can see, sequential search, here it will come. So whatever it will receive, -1 or index value, that will be stored into index. And if the index, here we are writing that condition, if the index value is -1, simply we are printing that the target isn't present in the list. If the index value is -1, the given target is not present in the list. And if the index value is not -1, other than -1, then what will happen? The control goes to the else part and it will print the target which you are looking for. Percentile D is present at index percentile D. So this first percentile D will be replaced with target, and second percentile D will be replaced with the index value which you got from the sequential search function. Okay, so this target will be printed over here and this index value will be printed over here. Okay, in our 62 case, 62 is present at index 4 in the list. Likewise, you will get a message. Here you can see. I have given the list of items 5, 6, 8, 1, 2, 3. This is my list because I said 6 items I need in my list. So it is reading 6 items. After reading 6, I gave the target to be searched as 2. Okay, target to be searched as 2. So what it is printing? Because we can see 2 is present at what index? This is 0th index. This is first index, second index, third index, fourth index. So 2 is present at index 4 in the list. Likewise, it is giving the outcome. 2 is present in the at the index 4 in the list. Likewise, it is giving. So quickly, I will try to write that program here. So I will include my header file. Okay, then I will declare my function because I'm going to use the searching technique through sequential search function that I'm declaring here. Declare the function declaration. Okay, my function will return integer value and name is, because index it will return. The name is sequential search. You can take any name, user defined name. Okay, input is list we give, target we give, as well as the size. Target will be of type integer. In the declaration, we just need to specify the data types. No need to specify the identifiers. So size we give. 3 things it will take. Now I'm writing my main. Okay, in it, what we have to first declare the list. So I'm saying I need list of some 20 items, any random number of items you can take, and one target and one size and one I. Okay, like this we need different variables. Quickly read the size of the list, enter the number of items, enter the number of items, read those items, scanf, percentile D, ampersand, size. Okay, now read that many items, printf, enter, sorry, double quotations, enter percentile D items into the list. Okay, what is percentile D? Size. Okay, so it will ask you, suppose if you are giving the size as 6, it will ask you to enter 6 items into the list. So that size, through loop we read that one, I equals to 0, I must be less than the size I plus plus and it should be the list size ma, because we took the maximum size as 20 only. So maximum how many elements we can input? Only less than 20 we can input ma. That also you give a caution, okay, to the end user. So scanf percentile d, one at a time we read in the loop. So ampersand list of I. Okay, this will read all items, whatever number of items you are saying, that many items it will read into the list. Okay, after that, after reading the list, uh, read the target. So printf enter the target, okay, to be searched in the list. Like that you can, but I'm writing very short and simple. So read the target, scanf percentile d comma ampersand target also with asma now. So now calculate the call the function sequential search, whatever we declared over here, and store the return value into index. So that you write here. So what we have to index value return చేసే value index లో రావాలి కాబట్టి index equals to call the function sequential search of ఏమేం పాస్ చేయాలి మనం pass చేయాలి. First thing we need to pass the list, second thing we said target, third thing we said size. These three things we need to pass. Okay, now you write the definition. So this is the function call. Whatever we have done here na sequential search, it is the function call. Okay, now we are writing the function definition. Function definition. So how we write ma? Return type is int sequential search of, receive the actual parameters into formal parameters, list into list, target into target, size into size. From here to there you just take the copy. So int list of, don't put the size, and next is target we need to, so int target, same attribute name, formal and actual, same parameter names I'm taking, nothing will affect ma. Okay, then int size, same size parameter I'm taking. Then init, what we have to, you just declare one index, because this we need to return. Okay, so now perform the comparison. How come? For all, start with index value 0. Okay, then index, it should be lesser than the size, and after that index plus plus. Okay, init will take a loop, and here what we do, yeah, if we compare list of what index, list of index is equals to target ma, target, then if it is true, what we have to return, return index. If this is true, return index, and this brackets not required ma, because this will act like a single statement to for, and this will act like a single statement to if statement. So if none of these are true, if none of the item is matched with the target, simply return -1. That's it. Okay, if any of the item is matching, there only the function will return. Okay, with that index value, the function will return. If none of the item is matching with the target, then it will return with -1. And whatever is the case, whether it is returning with the index or whether it is returning with -1, in both cases, the respective values will be stored in this index. Main function portion, called function portion, index value will be updated. Okay, accordingly we need to make the decision. Okay, so how come? If your target, if your index equals to -1, what does it mean? Our search is unsuccessful. So printf percentile, how we conclude it? Percentile d is not present in the list. That's it. Percentile d is not present in the list. And what is that percentile d? Our target only. Our target is not present in the list. In the else case, what we have to printf percentile d is present at percentile D index in the list. Okay, so what will be my first percentile D? The target. And what will be my second percentile D? The index. So likewise, and then after just come out and return 0. Okay, likewise it will go. Okay, as simple as it is, just we need a clear understanding before we type this program, before we write this program. Just we need some clear understanding of the concept, so that you can write. And there is no way, definitely from this five approaches. In your fifth unit, we have only 5 approaches, linear sequential search, binary search, bubble sort, insertion sort, selection sort. 3 sorting techniques, 2 searching techniques. 1 LAQ compulsory will come. 100% damn sure 1 LAQ compulsory will come. Okay. సో ఈ 5 టెక్నిక్స్ నుంచి, అల్గోరిథమ్స్ నుంచి 2 సెర్చింగ్ టెక్నిక్స్ ఉన్నాయి, 3 సార్టింగ్ టెక్నిక్స్ ఉన్నాయి కదా. ఈ 5 టాపిక్స్ నుంచి, 5 క్వశ్చన్స్ నుంచి ఒక క్వశ్చన్ మాత్రం కంపల్సరీగా ఉంటుంది మీ ఎక్స్టర్నల్ పేపర్లో. ఓకే, సో ప్రాబబిలిటీ చాలా ఎక్కువ ఉందమ్మా. ఈ 5 కాన్సెప్ట్స్ నుంచి ఒక LAQ వచ్చే ఛాన్సెస్ చాలా ఎక్కువ ఉన్నాయి, ప్రాబబిలిటీ చాలా ఎక్కువ ఉన్నాయి. సమ్ టైమ్స్ దే మే ఆస్క్ 2 ఆల్సో. సర్చింగ్ టెక్నిక్స్ నుంచి ఒకటి, సార్టింగ్ టెక్నిక్ నుంచి ఇంకొకటి కూడా అడగొచ్చు, చెప్పలేం. ప్రాబబిలిటీ ఉంటుంది, చాలా హెవీ ప్రాబబిలిటీ ఉంటుంది. సో బీ ప్రిపేర్డ్ ఫర్ దీస్ అల్గోరిథమ్స్ విత్ ఎగ్జాంపుల్ ప్రోగ్రామ్స్. కంపల్సరీ ప్రోగ్రామ్ రాస్తేనే మనకు ఫుల్ మార్క్స్ వచ్చే స్కోప్ ఉంది కాబట్టి ప్రోగ్రామ్ కంపల్సరీగా ప్రిపేర్ అవ్వాలి. అండ్ ఎగ్జాంపుల్ కూడా ప్రిపేర్ అవ్వాలమ్మా. ఎగ్జాంపుల్ ఆల్సో యూ నీడ్ టు ప్రిపేర్. ఓకే, సో జస్ట్ కంపైల్ ఇట్. Just we need to save this one. Sequential search algorithm.c. Hit enter. As you can see, there are no issues in my code, whatever I have written. There are no issues. Compilation time without any errors it is showing. So just execute, run the program. As you can see, it is asking me to enter the number of items. I am inputting 6 items. Okay. So this less than 20 I have to put here, number of items entry appude manam less than 20 and pettali. So just I will remove this, and here, okay, here only I will put that one less than 20, and this less than 20 you just remove. Save one more time, just compile. It got compiled successfully. Run it. Yeah, it is asking me to enter the number of items. That should be less than 20. I am inputting 6, and it is asking me to enter the 6 items into the list. I am inputting 6, 4, 8, 1, 9. Okay, likewise 5 items, one more item, 7. Okay, some random items I have given. As you can see, the list is not in sorted order. Okay, then I am hitting enter. Now it is asking me to enter the target. I am giving the target to found 9 in the given list, to find 9 in the given list. So it is showing me 9 is present. 9 is present at 4th index, because this is your 0th index. This is 1, 2, 3, 4 at 4 index in the list. So this is how it will return the output. Try one more time. Item not found case, target not found case. Just I am inputting 5 items. So it is asking me to input 5, 2, 4, 1, 7, 9. Okay, 5 items over. Hit the enter. Now it is asking me to input the target. I am searching for 3, which is not existing in the list. So I am getting the message accordingly. 3 is not present in the list. This is how we can do it. We can achieve it. ఓకే, యాజ్ సింపుల్ యాజ్ ఇట్ ఈస్. జస్ట్ ఇక్కడ జస్ట్ మనం ఏం చేసాం, రీడ్ చేయడం. ఫస్ట్ లిస్ట్ లో ఐటమ్స్ ని, ఎన్ని ఐటమ్స్ కావాలని రీడ్ చేస్తున్నాం, అన్ని ఐటమ్స్ ని లిస్ట్ లో రీడ్ చేసుకుంటున్నాం. తర్వాత టార్గెట్ రీడ్ చేస్తున్నాం. సీక్వెన్షియల్ సెర్చ్ ఫంక్షన్ ని కాల్ చేస్తున్నాం. ఫంక్షన్ రిటర్న్ చేసే వాల్యూని, ఇండెక్స్ ని ఇండెక్స్ లో స్టోర్ చేస్తున్నాం. అండ్ బేస్డ్ ఆన్ దట్ ఇండెక్స్ వాల్యూ, ఇఫ్ ది ఇండెక్స్ ఇస్ -1, we are saying item is not present, and if the index is other than -1, we are saying item is present at that index. Okay, simple program ikkada. And then inside the function definition, what we are doing, we are taking a loop and we are comparing each item in the list, because here you can see index will iterate from 0 till the size. Okay, 0 till size minus 1. So every time in the first iteration, list of 0 will be compared with target. Then in the next iteration, list of 1 will be compared with target. Likewise, if item is found at a particular index, then index will be returned. And if the item is not found at any of the indexes, then this loop will break. Then this loop will break and minus 1 will be returned, because the control comes out and immediately returns the minus 1. So whatever you return from here, the same thing will go inside this index, and based on that index only we are concluding our search result. Okay, if it is minus 1, no item found. If it is other than minus 1, the item is found at that index itself. Hopefully it is clear. Okay, this is this particular thing, the concept of linear sequential search. We call it as a linear sequential search. Okay, this particular searching technique, when we have to apply, if the list size is small and if the list is unordered, not in order, and if the list if the searching operation is less frequent, less number of times we are performing searching, means you have to go for linear sequential search. And the other searching technique, the second type of searching techniques, it is comparatively very slow. Your linear sequential search, it is comparatively very slow with binary searching technique. Okay, binary searching technique is it is fast. Okay, if we have an array of 1 million elements, let us assume inside an array we have 1 million items. So in the worst case, if there is no item in the list, if the target is not present in the list, then at the worst case, how many comparisons you have to do? 1 million comparisons you have to do before concluding that the item is not there in the list. It is an what we call wastage of computational resources. Even though the target is not available in the list, before we conclude, before we confirm that the target is not available in the list, how many comparisons we are making? 1 million comparisons we are making, and obviously it is not the right thing to follow. Okay, so in the worst case scenario, we are unwantedly, I mean without our intention also, we are making 1 million comparisons just to confirm that the item is not available in the list. Okay, so but linear sequential search, it is the only option if the list is not in sorted order. See here, if the given array, if it is not in sorted order, our only option is what? We have to go for the linear sequential search only. Okay, if the array is not in sorted order, this is the only option. So when they are saying these three statements, they are talking about linear sequential search only. Okay, and but if the array is sorted, we have an ordered array, we have a sorted array, we can use a more efficient algorithm, that is your binary search. Here you can see that is our binary search. Okay, probably based on those three parameters, we already said that whenever we have more than 50 items in our list, okay, more than 50 items in our list, we have to go for a binary search algorithm. Okay, binary searching technique. Okay, as simple as it is, because we have many difficulties, many problems in sequential search, like whenever the size of the list is very large, we unwantedly performing unwanted comparisons just to confirm whether that the item is not present in the list in the worst case scenario, and if and we also said that if the list is not the sorted list, then this is the only option. But if the list is sorted, we can go for a more efficient technique called as binary search. Okay, so about this search, how it works. Concept is pretty simple, First, mathematically, I will explain. Then we'll do the programming thing also, program example also on that one. Okay, given the list, what we do is, suppose a list is given to you. What we do is, We know the starting index that we call it as first, okay, and we know the last index that we call it as last, okay, and we calculate mid, okay, we calculate mid such that these three are variables ma. First will be the starting index. First will be the starting index, and always it is 0. And last, not always, ma. In the first iteration, it will be 0. And last will be size minus 1, maximum size minus 1. Say, suppose if you have 10 items in your list, then the size will become what? Then the last will become 9. Size is 10, so last will become size minus 1, we said now, so last will become 9. Last index value, this is the first index value. Okay, so based on these two, we calculate mid. Mid, how we calculate? Simple formula. Always, whenever we go for mid calculation, same formula we use, and very simple formula we use. That is something like average of these two. That is first plus last divided by 2. First plus last divided by 2. Okay, divided by 2. Using this formula, we calculate the mid. And once we calculate the mid, we always compare the target with list of mid only. We always compare the target with list of mid only. Okay, list of mid will be compared with target. Compare with target. Okay, if list of mid is I mean, if it is equal, if it is exactly equal, what we do? If it is exactly equal, we return index, we return mid, mid index we return mid. Okay, and if it is not equals to mid, if it is not equals to mid, what we do? We check whether it is greater than or less than the target. Okay, if it is greater than, then we modify first. If it is greater, we modify first, and if it is lesser, we modify last. Accordingly, we calculate one more time new mid, and based on that new mid value, one more time we do the comparison. If it is equal, we return the mid as index. If it is not equal, we compare whether we check whether it is greater or lesser the target. Whatever list of mid item we are comparing, whether it is greater or lesser, we do the comparison. If it is greater, one more time we modify the first only, and if it is lesser, again we modify the last only. So that is how it will do. So basically what it is doing, see, every time it will divide the given list into two equal parts, two halves. Okay, it will divide the complete list into two halves, and with every what we call iteration, your list keep on gets halved until we reach the target, or the item is not found in the list. Until until the target is found or the item is not found in the list. So that's the reason there are two possible cases for this binary search technique. The first one is the target found case, and the second one is the target not found case. And very crucial, very important, and very somewhat comparatively linear sequential search anta easy kadamma, koddiga complicated approach. Okay, so the binary search starts by comparing the data in the elements in the middle of the list. We are not comparing with the first one, we are comparing the target with the middle of the list. And middle of the list, how we are calculating? Just first plus last divided by 2, whatever index value we will get, with that index value we compare the target. Okay, this determines if the target is in first half or in the second half. If it is not matching with the mid, okay, if it is not matching with the list of mid, then what we have to do? We need to check the comparison, greater or lesser అని check చేయాలి. If the item is greater, that means the item will be available in the item may be available in the second half. If the target is lesser than the list of mid, that means the item is that the item may be available in the first half. And as we can apply this binary search only to the sorted list. Unsorted list ki manam ee algorithm ni apply చేయలేము. దేనికి అప్లై చేయొచ్చు? ఓన్లీ సార్టెడ్ లిస్ట్ కి మాత్రమే అప్లై చేయొచ్చు. ఓకే, టు డెమాన్స్ట్రేట్ దిస్ వన్ మా ఐల్ గో టు అన్ ఎంటీ what we call a slide. Take an example, very simple example how it will work. Already we have diagrammatic representation also, but just take a simple example so as to make it clear. So I'm taking just list of 6 items ma. 6 items తీసుకుంటున్నాను. Just take this as an example with 6 items: 1, 2, 3, 4, 5 and 6. And the list should be in sorted order ma. Don't take random elements in your list. List should be in sorted order. So I'm taking 3, 4, 7, 8, okay, 11, 13. As you can see, the list is in sorted order. So this is 0th index, this is first index, second index, third index, fourth index, fifth index. Okay, hopefully it is clear. So we said now we need first, we need last, and we need mid as well. Okay, initially what will be the first? First will be 0 ma, and what will be the last? Last will be 5. Okay, calculate the mid now, because we need to, and assume the target also I have to write now. Target, you assume target to be searched in the list. First item found case, target found case ki veldamu, and we are looking for this 11 target ma. 11 target. Okay, but target is 11. I need to find the 11 in this list, in this particular list, through binary search. So 11 is our target. First is 0, last is 5. So what we have to ma, in the first iteration we calculate the mid. We calculate the mid. Mid ela calculate cheyali? First plus last divided by 2. Okay, I'm writing formula. First plus last divided by 2. So what it is? First is 0 plus last is 5 divided by 2. So this is 5 by 2, and we are taking mid. All these as integers only we will take. First, last, mid, all these as integers. So 5 by 2 ante ento ostundama? 2.5 ostundi, but we are taking integer. So this will be 2. Okay, this will be 2. Then immediately what we do? Now mid 2 vachesindi kada. So we compare the list of mid. We compare the list of mid with this target. List of mid, target. Check whether both are equal. List of mid is what? List of mid is 7. Mid is 2 na. So list of 2. List of 0 is 3. List of 1 is 4. List of 2 is 7. So 7. Is it equal to target 11? No, not equals to. 11 ki equal kaadu. Is it, is your target greater than the list of mid? Yes, it is greater than the list of mid. It is not lesser, it is greater than the list of mid. So what will happen ma? There is a possibility that the target may be present in the second half, because we got the mid over here. 2 daggara manaku mid ochindi. This is your mid, current mid, and it is divided the list into 2 parts. Okay, first half, second half. So as your target is greater than the list of mid, the possibility is that the target may be present in the second half. Okay, second half lone untundamma mi target. So as you can see, by calculating this mid, we have if as there are only 6, in that 6 we partitioned into 2 equal halves. But if there are 1 million items, then any items manaku remove అయిపోతాయి లిస్ట్ నుంచి? 50% ఆఫ్ ది ఐటమ్స్ మనకు రిమూవ్ అయిపోతాయి లిస్ట్ నుంచి. 50% ఆఫ్ ఐటమ్స్ లో మనం చెక్ చేయాల్సిన అవసరమే లేదు, ఎందుకంటే అక్కడ మన టార్గెట్ ఉండే ఛాన్సే ఉండదు. As our target is greater than the list of mid, we need to focus on second half only now. First half is completely removed from our consideration. ఈ పర్టికులర్ పోర్షన్ ని చెక్ చేయాల్సిన అవసరమే లేదు. Now we need to check only this second half. ఇక్కడ నుంచి ఇంతవరకు మాత్రమే చెక్ చేయాలి. Okay, this is second half and this is first half. Now in the further proceeding, what will happen in the sense, this particular list will be considered as your new list for the operation. ఓకే, ఈ పర్టికులర్ లిస్ట్ మీకు ఏమవుతుంది, దిస్ విల్ బికమ్ ది న్యూ లిస్ట్ ఫర్ యువర్ ఫర్దర్ ఆపరేషన్. సో వాట్ ఐ సెట్, ఇఫ్ ది టార్గెట్ ఈస్ గ్రేటర్ దాన్, if the target is greater than the list of mid, then update first. మనం దీన్ని అప్డేట్ చేయాలి, ఫస్ట్ ని అప్డేట్ చేయాలి, లాస్ట్ ని అప్డేట్ చేయాల్సిన అవసరం లేదు. అప్పుడు ఆ కేసులో ఫస్ట్ ని ఎలా అప్డేట్ చేస్తామంటే, ఫస్ట్ ఈక్వల్స్ టు మిడ్ ప్లస్ 1, ఫస్ట్ ఈక్వల్స్ టు మిడ్ ప్లస్ 1 గా అప్డేట్ చేస్తాం. సో నా ఫస్ట్ ఏమవుతుంది, ఫస్ట్ విల్ బికమ్, ఫస్ట్ ఈక్వల్స్ టు మిడ్ వాల్యూ ఎంత 2. So 2 plus 1 equals to 3. Your first is 3. Last it will remain as it is. We don't modify last. Last ఎప్పుడు modify చేస్తాం, టార్గెట్ ఒకవేళ స్మాల్ అయితే, టార్గెట్ లిస్ట్ ఆఫ్ మిడ్ కంటే స్మాల్ అయితేనే మనం లాస్ట్ ని modify చేస్తాం. Whenever target value is greater than list of mid, we modify only first. So now last will remain unchanged. Last is 5 only. Okay, last is 5 only as it is. Now calculate one more time in the next iteration, calculate the mid value. What will be the mid? Mid equals to first plus last divided by 2. 3 plus 5 divided by 2. It is 8 by 2. It is 4. Okay, now we got the new mid. So check again, list of mid and the target. And the target. Okay, what is list of mid? List of 4. List of 4 ఎంత ఉంది, 11 ఉంది. Okay, and our target 11. So this is how, see, in only 2 comparisons we found the target. With these many items, in 2 comparisons only we found the target. If it is linear sequential search, how many comparisons we have to do? First we need to compare this, 1 comparison, 2 comparisons, 3 comparisons, 4 comparisons, 5 comparison. After in 5th comparison, we may encounter the what we call target. Okay, we may get the target. Take another example. Take another example. Target not. This is whatever we discussed over here. It is target found case. In binary search law, target found case. Target found case. And target not found case, target not found case. Okay, target found case లో algorithm ఎలా terminate అవుతుందమ్మా, by returning the index mid value, returns mid value. Whenever the target found, what it will do, it will returns the mid value. And if the target not found, how that case will end, in the sense, whenever your last value goes less than the first value, last value first value kante chinnaga ayipoyindi, okay, last value becoming lesser than first value, that means there is the item, the target which you are looking for, it is not available in the list. Okay, this particular condition. Whenever last value, ikkada last and first తీసుకున్నాం కదా, there is a condition that first should be always lesser than the last. First should be always lesser than the last in your algorithm. So whenever that particular condition is failing, whenever your last is becoming lesser than first, ultimately your algorithm will end with -1. ఈ కేసులో మనకి ఏం రిటర్న్ అవుతుంది, -1 రిటర్న్ అవుతుంది, returns -1. So quickly we will do that here, that processing here. I'm assuming my target as say 9. As you can clearly see that 9 is not available in the list, so it will become my target not found case. Just see how the algorithm will end here. Okay, now target is 9, as we are starting from the beginning. So first will become 0, last will become 5, and target is 9. What we need to do, we need to calculate the mid. Do that, calculate the mid. Mid is equals to first plus last divided by 2. So 0 plus 5 divided by 2, that is 2.5. So it will become 2 only. So quickly do the comparison. List of 2, it should be between list of 2 and target. What is list of 2? List of 2 is 7. 7, target is 9. Relation is greater than. So whenever greater than, we need to modify first because we need to test only the second half. So modify the first. First ni ela modify chestam? First will become mid plus 1. First equals to mid plus 1. So what is mid now? Mid is 2 here, you can see. Don't go for this recent mid only. So 2 plus 1, it is 3. Your first, just now we got 3. Last is unchanged. Last will remain 5 only. Calculate the new mid. Mid equals to first plus last divided by 2. So 3 plus 5 divided by 2. Okay. 3 plus 5 divided by 2, that is 8 by 2. It is 4 only. It is 4 only. So list of 4, how much it is? List of 4, 11. We are comparing with 9. Our target 9 we assumed. Okay. So as you can see, it is lesser. Your target is lesser than the mid, list of mid. Okay. Target is lesser than the list of mid. So we need to modify the last. Last ni ela modify cheyali ante last equals to mid minus 1. Last equals to mid minus 1. First ni modify చేసేటప్పుడు mid plus 1. Last ni modify చేసేటప్పుడు mid minus 1. So what is mid? Your latest mid, it was 4 minus 1. So your last will become, here I will write, last will become 3. First is unchanged in this case. Previous first only we will check, that is 3 only. Okay, 3, 3. And next is, next is we need to take the new mid. Based on these two, we need to calculate the new mid. Mid equals to, how much it is? 3 plus 3. First plus last divided by 2. So 3 plus 3 divided by 2, it is 3 only. So list of 3, how much? List of 3 is 8. And your target is 9. Okay. Target is 9. List of 3 is 8. So here list of mid we need to compare na. List of mid, that is list of 3. We got 8. This is your target. This is your target. What is the relationship? Again, target is greater than. Target is greater than the list of mid. So if the target is greater, what we have to do? We need to modify the first. First ni ela modify cheyali? Your first will become mid plus 1. First equals to mid plus 1. So what is the mid value? The latest calculated mid value, 3. So 3 plus 1. Your first is 4. Your first is 4. And what is last? Last we don't modify. Last from the previous case only. Previous case last was 3. So now just see your first and last. Your first became greater than last. Our condition was last should be last should be lesser than first. As you can see, last is becoming lesser than first. Okay. So here the algorithm will terminate and we consider the case as target not found case, as my last became the lesser than first value. Last in this case, last was 3 and first was 4. So last became lesser than first. So my algorithm will terminate here only. So the same thing we will see here. See how it works. We calculate 3 things, that is first, beginning of the list, last, end of the list, mid, middle of the list. Okay. These 3 variables we maintain in the algorithm. And first it is always 0. Last it is always maximum size minus 1. And mid it will be first plus last divided by 2. And it is an integer value. So a points లో వచ్చినా మీకు పర్ఫెక్ట్ ఇంటీజర్ వస్తుందమ్మా. అంటే 2.5 వచ్చింది అనుకోండి, we consider only 2. 3.6 వస్తే only 3. Likewise, we take only the integer. From this precision number, we take only the integer. Okay. And with that index ఎప్పుడు మనకు హోల్ నంబరే ఉంటుందమ్మా. ఇండెక్స్ లో మనకు డెసిమల్ పాయింట్స్ ఉండవు. ఇండెక్స్ హోల్ నంబరే ఉంటుంది కాబట్టి we are taking mid as integer and accordingly we are calculating the mid. Okay. So hopefully you understood. So as you can see here, I have written the formulae, first plus last divided by 2. Okay. So let us assume this is the given list. This particular list is given list, and we are looking for 22. Target is 22. So first is 0, last as you can see 11, and 0 plus 11 divided by 2. This will be something like 5.5, but we consider only the whole number. So that's why my mid became 5. So, and as you can see, the whole list is in sorted order. List sorted order lone undali, binary search apply cheyali ante. So mid 5, here it is 21. So 22 greater than 21. So this is my target. This is my target. And what is this? This is my list of mid. This is my list of mid. Okay. List of mid ante list of 5 అని అర్థం. List of 5. This is my list, and list of 5 I am comparing with target. Okay. And you see the relationship. Target is greater. So there is a possibility that target will come only in the second half. Only in the second half, not in the first half. So here you can see. My list is divided into 2 portions, and this complete portion I shadowed, means there is no possibility that my target will be available in this list, because 21 కంటే 22 పెద్దగానే ఉంది కదమ్మా. సో సెకండ్ హాఫ్ లోనే ఉంటుంది కానీ ఫస్ట్ హాఫ్ లో ఉండే పాసిబిలిటీ ఉండదు కదా. ఎందుకంటే ఫస్ట్ హాఫ్ లో నాకు టార్గెట్ కంటే చిన్న ఉన్న ఐటమ్సే ఉంటాయి. isn't it? Whatever items I'm looking for, all those will be lesser only in the first half. But my target, I found that it is greater than list of mid. List of mid is 21 and my target is greater than that. So I'm modifying my first. As you can see, I modified only first. First ela modify chesanu nenu? First equals to mid plus 1 chesanu. Mid plus 1 chesanu. Mid entundi 5. 5 plus 1, 6. So my first became 6. Last remained as it is 11, and I calculated my new mid. For this second half list, only for this list, I calculated my mid. So mid ela calculate chesanu? 11 plus 6 divided by 2. So how much it is? 17 by 2. This is something like 8.5. So 8 only we will consider. So mid became 8 now. Okay. Again, list of mid I am comparing. Here, list of mid. This is what? This is my target. And this is my list of mid. List of mid. That is nothing but list of 8. Here, 8. List of 8 is 62. So 62 we are comparing with 22. Again, target is lesser now. Target is not greater. Target is lesser. So target less అయిందంటే ఇక్కడ నుంచి ఈ పోర్షన్ లో మన ఐటమ్ ఉండే ఛాన్సే లేదు. So it can be in these two only. Okay, because lesser undi kabatti it should be lesser than 62 only. It should not be greater. It will not be greater than 62 target. So what we have to, here we need to modify last. Here we are not modifying first. First is remained as it is. Ikkada 6, ikkada 6 మీరు చూడొచ్చు. Here also we have 6, here also we have 6, not modified. Only last got modified. How we are calculating last? Last equals to mid minus 1. Mid was 8 minus 1, so it is 7. Okay, last you can see we got 7. First is 6. Calculate the new mid. How we calculate? 6 plus 7 divided by 2. That is 13 by 7. That is 12. Sorry, not 12. 6.5. So we consider only 6, and your mid became 6 now. Okay. Now again you compare your target. This is your target, and this is your list of mid. What is list of mid? List of 6. So list of 6, as you can see, it is 22, and our target is also 22. It is a perfect match. So if it is a perfect match, what we have to return? We have to return mid, and the function terminates here. By returning mid value, function terminates. Okay, hopefully you understood. So this is what target found case. Okay, that's complete calculation. Whatever I have done there now, it is shown here also. You can go through it. Then the target not found case. So target not found case in the binary search is something when we searched all the possibilities and didn't find the target. Okay, we searched all the possibilities and didn't find the target, means that we call it as target not found case. So this is done in the binary search when the first becomes greater than last. Okay, always last should be greater, first should be smaller. Okay, first should be smaller and last should be greater. But if your first becomes greater than last, then the function terminates. Then the function terminates. Okay, by returning -1, the function terminates. So this is how we conclude the target not found case. Here I explained that one. See here, target was 11 and we are looking for 11, and you can clearly see that 11 is not there in the list. So this will go like a target not found case. Initially, first is 0, last is obviously 11, and based on that 11 plus 0 by 2 we calculated 5.5, so 5 only we take, so mid became 5. So compare the list of mid. List of mid is what? List of 5, that is nothing but 21. This is a list of 5. Okay, and what is this? 11. This is target. Clearly you can see that target is smaller than 21. సో 21 కంటే చిన్నగా ఉంది కాబట్టి ఈ కంప్లీట్ లిస్ట్ లో మన టార్గెట్ ఉండే స్కోపే లేదు. మై టార్గెట్ విల్ బి అవైలబుల్ ఓన్లీ దిస్ ఫస్ట్ హాఫ్. ఓకే, సో ఫస్ట్ హాఫ్ లో ఉంది కాబట్టి మనం ఏం చేయాలి? ఈ లాస్ట్ ని మోడిఫై చేయాలి. లాస్ట్ ని ఎలా మోడిఫై చేయాలి? మిడ్ -1. వీ హ్యావ్ టు షిఫ్ట్ దిస్ లాస్ట్ ఫ్రమ్ హియర్ టు హియర్. Here, that is what I have done. You can see here. Okay, mid value 5. So we are modifying last. How? Last equals to mid -1. So 5 minus 1, we got 4. Now new last is 4, as you can see here. Old first is 0 only, that we take as it is because we no need to modify first. So once again you calculate the mid. Mid how much? First plus last divided by 2. So 0 plus 4 divided by 2, it is 2. So we got mid value as 2. Once again, compare the target. Our target we said 11. So compare the target with the list of mid. We got 2 as mid. So list of 2. How much? It is 8. So this is list of 2. We are comparing. Now you can see 11 greater than 8. Target again it is greater than. So there is no possibility. This is my mid. There is no possibility that I found my target in this. My target, there is a possibility that my target will be somewhere in these two only. Okay, so if it is like this, now what I need to modify? I need to modify my first value. Okay, modify the first. How come? First equals to mid plus 1. Mid plus 1. What is my mid? In the previous case, it was 2 here. It was 2. Let's put the 2 plus 1. It will be 3. My first, it became 3. Last remained unchanged, 4 only. Calculate the new mid. So 3 plus 4 divided by 2. 7 divided by 2. 3.5. Take only the integer. Your mid value became 3. Okay. So now at list of mid, compare the target. What is list of mid? List of 3, because mid value is 3. List of 3, this particular one. List of 3. And my target as it is this one only. Again, target is greater than the list of mid. So what I need to modify? I need to modify my first only. Last will remain unchanged. Okay. Modify the first. How come? First will become once again mid plus 1. Okay. Mid is what? 3. Okay. So yes, 3. This is 3 plus 1. So first will become 4, as you can see here. First will become 4, and last from the previous case, so here we need to modify last only, ma. When we modify the last, na, it will go same. Okay, because mid is 3, 3 plus 1, so it will go like 4 only. Okay. Here some mistake is there. See, all 3 will become 4 only. Here this is also 4. This is also 4. When we modify the first will become mid plus 1. It is 4. Here there is a mistake in the diagram. It should be 4. And then You calculate the new mid calculate, mid will become what? Mid is first plus last divided by 2. So 4 plus 4 divided by 2. It is 8 by 2, so it will become 4 only. So your mid also 4. First 4, mid 4, last also 4. There is a mistake here. All 3 will become 4. After that, what we have to compare the target with list of mid. List of mid is list of 4. List of 4 is 14. Here you can see list of 4 is 14 and it is compared with 11, and as you can see it is less than 14. So less than relationship, we need to modify the last value because it is lesser, target is lesser. So modify the last value. So last will become what? Last equals to mid minus 1. Okay, mid minus 1. So what is mid value? Mid value we have 4 here. So put 4 minus 1, your last will become 3. So now it became 3. Last became 3 and first is 4. Obviously, first is greater than last or last is less than first. So your algorithm will terminate. Function terminates. Okay, because your first has became greater than the last. So algorithm terminate. This particular condition is matching. So algorithm will terminate. So quickly you see here the same thing we have written. So how to modify last, how to modify first, here you can see. Whenever the target is greater than list of mid, if this is true, we modify first. And whenever target is greater than list of mid, if it is false, that means target is less than list of mid, then we need to modify last. ఈ two conditions గుర్తుపెట్టుకోండి. And whenever we are comparing list of mid with target, if it is equal, return the mid. Okay, wherever it is equal, just return that mid, and if it is not equal, do the greater than less than comparison. Okay, like this. And how we are calculating the midma? Mid we are calculating first plus last divided by 2. Okay, initially as you can see, first is 0, last is max size minus 1, that is end of the list. Okay, and always there is a condition that first should be less than or maybe equal, but it should not be greater. First అనేది last కంటే greater కాకూడదు. That will become your termination point. Okay, if this is true, then what will happen? If function, if first value is becoming lesser than the, sorry, if your last value is becoming lesser than first, then we are returning minus 1. This is in the false case. In true case, we get into the loop body. Okay, because as you can see, it is a while loop. It is a kind of loop. Okay, so whenever this particular thing is true, we are entering into the loop body and we are doing all these. And whenever this particular thing is false, we are returning minus 1. Hopefully you understood. Okay, so quickly just see the program. Here also we are doing the same thing. We are reading the number of items. We are reading that many items into the list. We are reading the target. We are calling the binary search algorithm function. And based on the return value, index value, we are checking whether the item is present in the list or not present in the list. For both programs, sequential search aina, binary search aina, ఈ 22 lines of code same ఉంటుంది. ఓన్లీ ఇక్కడ మీకు ఆ ప్రోగ్రామ్ లో చెక్ చేస్తే మీకు SEQ సీక్వెన్షియల్ సెర్చ్ అని ఉంటుంది, ఇక్కడ మీకు బైనరీ సెర్చ్ అని ఉంది. హియర్ సేమ్ థింగ్, డిక్లరేషన్ లో బైనరీ సెర్చ్, అక్కడ సీక్వెన్షియల్ సెర్చ్. ఈ టూ డిఫరెన్సెస్ ఉంటాయమ్మా. రెస్ట్ ఆఫ్ కంప్లీట్ కోడ్ యూ చెక్, ఇట్ ఈస్ డిటో. There is no single difference between that algorithm and this algorithm. What changes in the sense, only the function definition will change. As you can see here, function definition will change. Okay, so quickly what we do, yeah, this whole thing, the top program, it is as it is. I will maintain only in place of sequential search, I will make it as binary search, BIN. And here also same thing, function call, make it as binary search. That's it. I'm not changing any other thing. Remaining thing as it is, remaining complete program as it is. So here function definition I need to change. I'm calling it as binary search. Okay, and here also we are reading the same thing, target and size, but index, along with index, yeah, there is no index because we return mid value, right? So first initially make it 0, comma last Initially it should be here. Size we are reading now, size minus 1. Size minus 1, and we also take one mid. Okay. Then instead of for loop, we'll take the while loop, and while loop ఎలా terminate చేస్తాం? First always less than or equals to last. Okay. If this is failing, we will return minus 1. Okay. ఈ loop నుంచి బయటికి వచ్చి we are returning minus 1. This whole thing you remove ma, of no concern now. This thing of no concern now. If the control is coming out of this loop, means this condition, if it is failing, we are returning minus 1. Else what we have to do? Inside we need to calculate the mid. Mid, how we calculate? First plus last divide by 2. This is how we calculate the mid. And what we do? If at all your target is equals to list of mid. Okay. If this thing is true, then return mid. That's it. Okay. And in the else case what we have to? We need to check. Else, in the else case, just check whether target is greater than list of mid. Okay. If it is, if the target is less than greater than list of mid, we need to change the first value. So first equals to mid plus 1. First ఎప్పుడు ఎలా modify చేస్తాం? List of mid చేస్తాం. Else modify last equals to mid minus 1. This is what we do. Only in the algorithm. This is it. Okay, this much algorithm we need to write. And now, yeah, everything I followed, it seems. Yes, no difference ma. Complete steps I have done. Just because I have given that sequential search name now, just save as, call it as binary search algorithm dot c. Hit enter. Now you can see program name got changed. Just compile it, run it. As you can see, it is asking me to input the items. So I'm inputting 6 items, and all 6 items should be in ascending order. Okay. We need to follow the order over here. So 3, 5, 9, 11, 13, 17. How many items? 6 items I have inputted. I have entered. Now enter the target. I will enter 13. Okay. So 13 is present at index 4. 13 is present at index 4 in the list. 0, 1, 2, 3, 4. So index 4, 13 item is present. Likewise. So just target not found case, we will quickly check. Okay, compile it, run it. Just input 6 elements. I'm saying 2, 6, 7, 9, 11, 16. Okay, 6 items. I'm asking it to check for 8. 8 is not present in the list. Likewise, it is returning. The only difference between sequential search and linear binary search is we need a sorted list to perform the binary search, and in less number of comparisons, we will get the output between sequential search and binary search. Binary search will take less computational resources, but whereas linear search will take more computational resources. Hopefully you understood. This is how we develop our algorithm. Yeah, this is it. And after this, we need to discuss the sorting techniques that we will see in tomorrow's class. Thank you. Hopefully you understood the concept. Thank you very much.